Hi! Oh my gosh, we're going through this gas laws practice quiz that technically is from 2022. That's not a EU 2022 though. Let's not forget that. Very, extremely important. On the real quiz, you will get all of these things, which would be the ideal gas law. Hopefully you know what they are at this point. This one is called the combined gas law. These are the R values for atmospheres, kPa, and millimeters of mercury. And then, of course, if you need to convert anything between atmospheres, kPa, millimeters of mercury, and or torr, which is the same as millimeters of mercury, then they're all right there for you. So we have all those things, and they'll be on every worksheet, every quiz, every test that you need. So you don't need to memorize any of those things. So let's get into it. So we got a couple of math problems here. And just like the real quiz, we'll have some math problems and we'll have some word problems. So let's start with the math problems. And first one, it says how many grams of ammonia are in a sample at a pressure of 135 and a volume of 750 millimeters at a temperature of 175 kPa. So it looks like in this problem we're solving for grams. Grams, we got to solve for moles first. Again, I like to rearrange this, but you don't have to. You can do it all sorts of ways. You can plug the numbers in directly and simplify. Maybe I'll try one of those later. But for this one, let's do it straight and rearrange it. So if I'm solving for a number of moles, I'm dividing both sides by R and T. So number of moles equals PV over R and T. And I'm going to use that equation to solve this question. And so start with number of moles. Number of moles in this problem is what I'm looking for. Wait, I'm done. So not start with moles, start with pressure. The pressure in this problem is 135 kPa. Then we've got volume. Volume in this problem is in milliliters. It's got to be in liters for the ideal gas law. So 0.75 liters, you divide it by 1,000. You can't plug in milliliters directly to the ideal gas law. And if that confuses you, then you should always just convert to liters, and that makes it easier for your life. Next, we've got the R value. The R for kPa is 8.314. And the temperature in this problem is 175. 175 plus 273 Kelvin, or to get to Kelvin, gets you 448 Kelvin. So in this problem, you're going to take 135 times 0.75 divided by 8.314 times 448, and you end up with about 0.0272 moles. It's not a very good zero. You guys deserve better. 0.272 moles of ammonia. That would be nice. But this question, as you can see, asks for grams of ammonia. So we got to convert those moles into grams. You need the molar mass of ammonia from the periodic table, which is 17. So you say 17 grams of ammonia. This is going to be on top because you want your answer in grams. You want to cancel out moles. So 1 mole of ammonia there on bottom. Notice how the moles cancel out. So if you do that math, 0.0272 times 17, you get 0.46 grams of ammonia. Where should I write that? I guess right here? No, I don't like it there. Equals 0.46 grams of ammonia for your answer. Highlight it. There it is. That's the whole thing. So in this problem, we're solving for grams first and then converting to moles. Solving for moles first and converting to grams at the end in that problem. Next one is another ideal gas law problem. I know that because it says the word moles right there. So moles or grams means the ideal gas law. So I have 6 moles of gas at a temperature of 95 degrees Celsius and a volume of 20 liters. What is the pressure of the gas? You get to pick in this problem whether you want it in kPa, millimeters of mercury, or atmospheres. So in this problem, we'll solve for pressure. Pressure, if you rearrange. Oh, yeah, I said I was not going to rearrange, even though it's way easier. And I'm mad at you for making me not do it. So PV equals nRT. Let's plug the numbers in directly. So in this problem, I've got 6 moles of gas, temperature of 90. What is the pressure? Oh, okay, so the volume is 20 liters. I'm solving for pressure. Volume is 20 liters. This is going to be an equal sign. And what do we get next? 6 moles of the gas. The R, we get to pick. I'm going to pick for atmosphere, so I'm going to pick 0.0821. You can pick for kPa or for millimeters of mercury. Whichever one you pick is going to give you that pressure. So if you pick 8.314, your answer is going to be in kPa. If you pick 62.36, your answer is going to be in millimeters of mercury. And what's last? Temperature 95 degrees Celsius is going to be 368, that's not a 6, 68 Kelvin. So then we're going to divide both sides by 20 to get pressure. Okay, so divide both sides by 20, and you will find that the pressure in atmospheres is 9.06 atmospheres, which is the same as saying 916 kPa, which is also the same 9.06 times 760 as saying 6,885.6 if you did it in torr or millimeters of mercury, 6,885.6 if you did it that way. But you don't have to. Any one of those, they're technically equivalent, and that would be the right answer. So there you go. Last one of the math section. Oh, actually, it's not the last one. Why can't I read? We've got 22 liters of a gas held at a temperature of 400 K to contain it with a pressure of 6 atmospheres. What's the pressure of the gas if I decrease the temperature to 250 K and decrease the volume to 15 liters? So this looks like a combined gas law problem. I don't see any mention of moles or grams. So let's plug in the numbers directly. And sometimes it helps just like write out like first volume, first temperature, first pressure, and then I've got a new temperature and a new volume, and I'm solving for second pressure. So here's my 2 and my 2 there. So let's see, we got 22 liters, my first volume. First, let's see, oh gosh. First pressure is 6 atmospheres. First temperature is 400 Kelvin. Next, I've got the other side. I've got 15 liters for my new volume, solving for a new pressure, and my new temperature is 250 Kelvin. I think most people like to solve this by simplifying both sides. So to do that, you're going to have something like 0.33 right there on this side, and then you're going to have on this side, if you do 15 over 250, something like 0.06 times P2. And then if you want to solve for P2, you divide both sides by 0.06 like this, and also this, and you get your answer as P1 equals 5.5 atmospheres. 5.5 ATM. And we know it's atmospheres because our first pressure was also in atmospheres. So there is the answer to number 3. In number 4, we're going to convert 1.51 ATM to millimeters of mercury. That's where you're going to use this guy right here. I'll draw a line right there. And that row of equal numbers allows you to convert between any pressure. So if I start with 1.51 atmospheres and I want to convert that into millimeters of mercury, I say that in 1 atmosphere is equal to 760 millimeters of mercury. So I'm going to write 1 ATM on bottom so it cancels out, and then 760 millimeters of mercury on top. I'm going to take 1.51 times 760, and you end up with 1,147.6, and the label would be either torr or millimeters of mercury. They mean the same exact thing. So that is your answer for number 4. Expect to do a conversion problem on the quiz, and also any number of mixed gas law problems. So, but it'll look pretty similar to that. For the words, this is just a sample, so I would definitely study your notes when you're looking to make sure you know what the words are. I just picked 2 questions, but flip through your notes, make sure you look at them so you understand things like the relationships, the graphs, what an inverse is, what a direct relationship looks like, STP you can see here, so make sure you know what that is. There were some things that we did in the notes that would fit here, and I happened to pick just 2 of them. So in this first problem, it says, what does STP stand for, and what numbers or units does it mean? STP stands for standard temperature and pressure. That's not how you spell it. And the units, does it mean? Well, for the standard pressure, any one of these works right here. Okay. Usually you just say 1 ATM. It's basically the pressure at sea level. So usually you say 1 atmosphere. And the temperature is 0 degrees Celsius or 273 Kelvin. So those are the units and numbers that are associated with standard temperature and pressure. Literally means a T and a P, and the numbers right there. And then I drew a bunch of these pictures, and we ask a question like number 6. I had some relationships on a graph or on the notes for you. This one says if I decrease the pressure of a sample of gas at a constant volume means don't worry about it, what happens to temperature? So if I decrease pressure, what happens to temperature? You might remember our little pictures. There was pressure and there was temperature, and they both point down, which means that there's a direct relationship. So if you decrease pressure, if you decrease this one, then that means this one also decreases. So you would say that it decreases there. So again, quick look at some of those problems that you might see on a quiz when we're talking about the mixed gas laws, with 2 gas laws, the ideal and the combined gas law. And don't forget, as I mentioned again, any number of word questions tomorrow. Make sure you familiarize yourself with some of those things that you have written down in your notes. Okay, this has been super fun. Hope everyone's doing really well. Take care of yourselves, and we'll see you soon. Okay, bye.